So looking at 8.2, solving absolute value equations, page 631. Just to get started here, looking at solving each of these. Quick, easy, linear. Subtract 2, so you get 3x equals 6. Divide by 3, you get x equals 2. If it's quadratic, equate to 0 and factor. X squared plus x minus 6 equals 0. And then we factor it, x plus 3 and x minus 2 equals 0. So our two answers, x equals negative 3 or x equals 2. Now looking at what we're doing with being able to read a graph, being able to find out where is the y value equal to 4. Well, find the y value of 4. And really what we're doing is we're making a line. Y equals 4. We're going to find where the intersection of y equals 4 and the original graph is. So we look for the points of intersection and we see, oh hey, it intersects here, there, and there when y equals 4. So there's your 3 answers for that one. And that happens at an x of negative 2, an x of 0, and an x of 2. Okay, so then when y equals 4, x is equal to negative 2, 0, and 4. Okay, then if we look at a y of 9, let's erase that one. If we look at a y of 9, well, at 9, it's up over here. You've got 2 intersection points at this point. So when y equals 9, you have, looks like about negative 2.5 and 2.5. So x equals negative 2.5
Chief McMullen reports the
and
team.
2.5. And then the last one that we do is where y equals 2. So y equals 2. You look at that and you see, oh, we've got 1, 2, 3, 4 different answers that would happen there. Okay, so those graphing strategies I just went over, looking at the intersection between two graphs, can be used for this. And it can be used for any type of a question when we have something equal to something. I've got y equals 4. Let's make that as one graph. Let's look then at y equals the absolute value of 2x and find out the intersection point between the two. The intersection point is going to be the solution. And then we can see they intersect here and there between the line y equals 4 and the absolute value of 2x. And then we look, where is the x value? In the original question, there was no y. We're looking for what x value gives us that intersection point. So we've got negative 2 and positive 2 as the two answers to this solution. Okay, so being able to use your graphing strategies from 8.1 are going to be very important here when you have to do it manually. You have to be able to graph one of these. I'm going to show you how to use your calculator again to find this, as well as using your manual graphing techniques. So we want to plug in one side, the left side as y1, the right side as y2. So the first one is going to be the absolute value of 3x minus 6. We're going to graph that one as y1 and graph 6 as y2. We're looking for the intersection of these two. So right here and right there. The way to find the intersection on the graphing calculator. Second, calculate, it's on the trace key. Going down to intersect, number 5. And moving, you can see you move along one of the curves. Up at the top here tells you which curve that you're talking about. Right now I'm talking about the absolute value curve, and it's on there. Is that the first curve that I want to find the intersection point of? Yes. Enter. Is this the second point? Second curve? Yes. Enter. Yes. Enter. It's going to give me that as one of the intersection points. 0, 6. I care about the x value. 0. So that's one solution. Now we've got to go through it again, find the other one. Second, calculate, it's on the trace key, down to intersect. But I now need to get my cursor way over closer to the other side. So take your cursor over so that it's close to this one. And is this the first curve, the first graph? Yeah. Second graph? Yeah. Find the intersection? Yeah. The other intersection is 4 and 6. I care about the x value, 4. So that tells me my two solutions are x equals 0 and x equals 4. 0 and 4 are the two answers. Okay, so we've got find the x-intercept of the original graph. 3x minus 6 equals 0, so 3x equals 6, x is equal to 2. Plug that on there. Then, looking at this graph, 3x minus 6, if it was not absolute value, it would have been a line with a y-intercept of negative 6 and a positive slope. The positive part I keep. The negative part, instead of being at negative 6, y-intercept, flips it up over to here to 6. And then I want to look for the intersection between that, which is the blue line, and y equals 6. So two intersection points. First intersection point at 0. Second intersection point would end up being at 4. So manually graphing, that's how you would find the two answers. Okay, and so just as I showed you, you can use your graphing calculator to find the intersection between two lines. So you would take y1 and y2. The two different y1 from one side of the equation, y2 from the second side of the equation. And then find your intersection points between the two of them. And if we look at that, we've got 1, 2, 3, 4 different intersection points that you have to worry about. And using the strategy that I just showed you, you would find all of the intersection points. And all we care about is the x component of the intersection point. Okay, so looking at the first 2a, we want to graph two different parts. Okay. Your first line is going to be y equals 3, y1 equals 3. Second graph is the second side, y2 equals the absolute value of 3x squared minus 3, and we're looking for the intersection point of the two. Point or points. Let's go to the graphing calculator. So plug them in. Your y1 is 3. Your y2 is the absolute value of 3x squared minus 3. And then we graph those. There's the first one, and there's the second one. And we need to find the intersection points of these three things. So we've got 1, 2, 3 intersection points. Doing the same thing, second, calculate. We want to find intersection points, number 5, and go closest to this intersection. 1, 2, 3. So negative 1.41 is the first one. Do the same thing again. Second, calculate. Number 5. Go closer to the next one. Enter, enter, enter. And we gave us that one over there, 1.41. And okay, so we've got the two different intersection points. One was negative 1.4142 dot dot dot. We also had the positive 1.4142 dot dot dot. The hardest one to always find is when it catches right on a maximum or minimum point. So let's go back to that calculator and look. If we zoom in on this, actually if you can zoom in, if I hit zoom in, you can see here that there's an intersection point right there at the 0 as well. And so we've got a third one. And the calculator is not really good at being able to find those. So you have to look for those very carefully as well. So then the third one is x equals 0. So 3 different intersection points. Alright, so let's go back to Zoom Standard. You always want to start on Zoom Standard, and then let's put in the second one. So then we're doing y1 for one side and y2 for the other side. Plug those two in. Move the graphs out. y1 is the absolute value of 2x squared plus 4x minus 1. And the second one is negative 2. Graph those. And noticing this one, they don't even intersect. There is no intersection points between the two of these. Our second line would have had to have been somewhere up above the x-axis for there to be an intersection point. And you're going to find that a lot of times when you have the absolute value and you have it equal to a negative number, it's not going to happen. Because this will always be positive, so you can logically see there's not going to be any answer. So no intersection. No intersection means no solution. Okay, so an absolute value equation we can have anywhere between 0 and 4 solutions. Let's look at the different ways. Okay, looking at that first graph, well, if you have, like we had in that last example, if we have a line that's below it, there's going to be 0 solutions. If we have a line that just crosses here, but this one, that one's a 2 solutions. Okay. This one, crossing here, 1, 2, 3, 4 solutions, and anywhere's up above that little, sorry, that one's 4 solutions. We also have 2 solutions happening up above that maximum. 2 solutions would be up here as well. 1 solution would only occur when we're right at a vertex, such as this. So anywhere from 0 to 4 solutions could occur. Okay, so if we use a graphing technique, very often we're just going to get an approximate answer, a decimal answer. Well, we want to be able to get an exact value. So algebra starts coming in there. So we're going to look at an algebraic strategy. The algebra, we need to look at that piecewise that we did in 8.1. We need to break up any of our absolute values into the 2 parts, a positive case and a negative case, case 1 and case 2. As you can see here, we've got the positive case, which is really just taking what's inside. That's going to happen when it's greater than or equal to 0. We've got the negative case, the second case, by putting a negative sign in front and then distributing it in, when it's less than 0 there. Working through then, solving for the x, we get negative 1 over 2. That's when this first case will happen when x is greater than or equal to negative 1/2. The second case, the negative case, happens when x is less than negative 1/2. That's exactly the same thing that you did with your piecewise functions. So now we're going to solve these algebraically. Taking the positive function, color coordinate these, positive function, and looking at the negative function. Positive function gives us one answer. Negative function, the second case, putting a negative in front, solving through, gives us a second answer. A negative case. The problem with absolute value functions is by doing this case 1, case 2, positive case, negative case, we lose some of the information. Just like when we did radicals, we squared them, we lose some of the information. We have to verify when we change and we do something different. So you must always, always, always verify. So must always verify. Even if the question does not ask you to verify, you must verify absolute value functions. The way that we verify, plug it in. Take the original, substitute it in, make sure that left side equals right side. Plug it into the original absolute value function, not into the case 1, case 2 things. You have to plug it into with the original absolute value. If it equals, by plugging it in, you get it equal to 2, which was this answer here, then that is a solution. 1/2 works. It equals 2, negative 3/2 works. Those are both solutions. If they don't work, then we've got an extraneous situation. You can always verify them on the graph as well. If it's on the graph, they are real answers. All right, so looking to solve this algebraically, we need to look at case 1 and case 2. Case 1, we're going to always call the positive case. Case 2, I'm going to call the negative case. So when does case 1 occur? Well, from that piecewise function information, take what's inside, 4x plus 6. That's where it's greater than or equal to 0. Solving through, we get when x is greater than or equal to negative 3/2. So that's when we're using case 1. We're using case 1 when the x values that we're talking about are greater than or equal to negative 1/2. Case 2 occurs when you've got the 4x plus 6 when it's less than 0. This one happens when x is less than negative 3/2. So case 1, we use the positive value. So x plus 8 is equal to the positive 4x plus 6. So I'm just having a positive sign in front of the brackets. Case 2, the negative case, occurs when we've got x plus 8 equal to negative 4x plus 6. There's the two different cases. Now we have to solve each of these algebraically and then verify. So an absolute value equation really kicks off two equations that we have to solve. So let's solve the first one. Get the x's to one side, get the numbers to the other side. That's same as always. Okay, so I'll just take my x's that way, subtract x, subtract 6. And then 2 is equal to 3x. So x is equal to 2/3. There's our first solution. We don't know if it's the right solution yet until we've verified. Second one. distribute in that negative, so x plus 8 is equal to negative 4x minus 6. I'll add the 4x over this way, gives me 5x. I'll subtract the 6 over to this way, which gives me negative 14. Divide by the 5, x is equal to negative 14/5. You can't stop there. You have to verify them. So we got to check, is this the right answers? Okay, so two different ways of verifying. Method number one, verify. Plug those numbers into the original. So plug solutions into original question. That's method number one. Method number two is just to evaluate it based on what we said up at the top. Is the x value greater than or equal to negative 3/2? If that's true, this is a solution. If this is less than that, then that one's true as well. So I'm going to show you the second way of verifying. So we take our solution, which was 2/3. Is it greater than or equal to the negative 3/2? So to color coordinate for you, is my solution, does that meet the requirements that I said right up at the very beginning? And that's true. 2/3 is bigger than negative 3/2. So this one is a solution. So because that's true, I can box in this first solution and say it is a solution. Looking at the other one, I need to check, is negative 14/5, is that one less than, from here, less than negative 3/2? Color coordinate that for you. Here's that solution. Is it less than that one? And yes, it is. That's a good one. So this also is a solution. So those two solutions verified. Two different methods of verifying. First one, plug those ones back into the original, right to here. I could take 2/3, plug it in for the x, plug it in for the x, work left side, work right side, see if I get the same answers on both. Then take this one, plug it into both sides, work it through, see if I get the same on both sides. The second method tends to be a bit easier when you're dealing with fractions especially. Okay, example number 4. Solving this one algebraically. Case number 1. That's the positive case. So this is going to be, and let's look at here, we're going to say that 4 is equal to negative 3x minus 2 squared plus 4. Case number 1 happens when we just make that, change that to brackets, and it's I don't change anything inside. All right, start solving for it. So subtract the 4 over. I got 0 equals negative 3, x minus 2 squared. Divide that over, the negative 3 over. I got 0 equals x minus 2 squared. Square root both sides. So x minus 2 equals 0. And then take that over, x equals 2. There's the first one. We'll verify it at the end here. Let's do case number 2. And that's the negative case. That's when we have 4 equal to negative bracket, negative 3, x minus 2 squared plus 4. Distribute in your negative. 4, and careful, it doesn't change the sign inside here. So it might be a little bit safer to just divide the negative over to the other side. So you've got the two options. And I'll do that. I'm just going to divide my negative over to this side to say it's negative 3 x minus 2 squared plus 4. And now we just start, again, solving for solving for x. So subtract the 4 over, we got negative 8 is equal to negative 3 x minus 2 squared. Divide the negative 3 over. So now we've got x minus 2 squared equals 8 over 3. Square root both sides. X minus 2 is equal to plus or minus the square root of 8/3. We don't like to leave radicals in the denominator. You've now learned that. We now need to rationalize the denominator. So let's do that first before we get moving too far. I'm going to actually do it on the side here for you. Square root of 8 over the square root of 3. Give them each their own square root. Square root of 8, simplify that first. That's 2 root 2 over the square root of 3. Now we rationalize. Multiply by the square root of 3 over the square root of 3. All the different chapters start coming to play here together. Which gives us 2 root 6 over 3. Let's bring that back in. Minus 2 equals plus or minus 2 root 6 over 3. And add the 2 over. So x equals 2 plus or minus 2 root 6 over 3. That means at this point we have x equals 2 as one option, x equals 2 plus 2 root 6 over 3, and x equals 2 minus 2 root 6 over 3. To verify these, we've got method number 1. Take the number, plug it in for the x. See if left side equals right side. Method number 2. Find, which is a little bit more difficult of a thing, but find where is this going to happen. The greater than equal to 0 and the less than 0. Method number 3 really is you could verify by checking on your graphing calculator as well. It's not an algebraic verification, but it is a verification as well. So for this one, if you plug that into your graphing calculator, we'll look at that as a method to verify this one this time. y1 is 4, y2 is the left side. And look, do you have 3 different intersection points? And yes, you do. So take this one here to a decimal just to make sure that it comes to the same decimal that you are calculating with your graphing calculator. Because they worked out, they verified, we do have all 3 answers as solutions. If one of them doesn't verify, then that one is an extraneous root and it's not included. So you could have, even though it says there's 3 here, maybe only 1 works.